This is No Bull IT bringing you another video here. Today I want to dive into DMVPN Phase 2 and Phase 3. As you see on my screen here, this is my current lab topology. We'll get into that. But firstly, I want to talk about what DMVPN is. Now, I do have a previous video showing how to configure DMVPN Phase 1. And if you want to check that out, we'll get more into the weeds here for Phase 2 and Phase 3. It's going to be the same underlay and same overlay, so that you can follow along with that. Now, a little brief overview of Phase 2. You have the three phases: Phase 1, Phase 2, Phase 3. Phase 1 is going to be only hub and spoke communication, where all traffic goes through the hub and to the spoke. Phase 2 and Phase 3 allow for spoke-to-spoke communication and tunnels formed. Now, the difference in configuration is that Phase 3 will have NHRP redirects, IP redirects on the hub, and the spokes will have NHRP shortcuts. So that way they can establish that on their routing table. And a couple of key important commands is split horizon and next hop self that we'll get into during this. And really one of the main differences is that when you use Phase 3, it changes your routing table, and Phase 2 does not allow for summarization through NHRP, while Phase 3 does. So we'll get into that right now. We're going to speed through some of the tasks here. We're going to establish the underlay routing with RIP, so that way we can establish, we're going to establish this from the ground up. The only thing that's configured is IP addresses, and the ISP network's already configured. So I'll take you through each one. So let's go ahead and get into the hub router here. Just clear the screen. So task 1, we're going to establish underlay routing with RIP. So we'll just do a quick ping test, right? I'm going to do hub router to spoke 1 first. So we're going to do Phase 2. So let's do a ping test of 20.20.20.1. As of right now, you see I can't ping, so we can't create the GRE tunnel, and we can't do anything else before we do that. So we're going to use RIP as our routing protocol, version 2, no auto summary. We're going to advertise our 10 network, okay, which is this guy here. Don't need to do the LAN. This is just the underlay to reach spoke 1. So that takes care of the hub. I'll go to spoke 1 here, and I'm going to do the same thing. Router RIP, version 2, no auto summary, network 20.20.20. That's taken care of. And then I'll go to spoke 2 as well. Oh, where's my spoke 2? This is down here. We'll do the same thing, router RIP, version 2, no auto summary. This network's going to be 30.30.30.30. Bada bing, bada boom. Okay, now we'll go back to the hub. We'll see here, can we ping 20.20.20.1? Can we ping 30.30.30.1? Great. So we have now the ISP router is configured with a RIP already for the 10, 20, and 30. So that way, I don't have to do that already. And, theoretically, if you're using your ISP, you won't have any configuration to do with that. So we have connectivity here. If we do show IP route, you see we have RIP right there with an administrative distance of 120. 20 network, 30 network. So we're good to go. Okay. So task 1 is complete. We established RIP for reachability. Now let's do EIGRP for the overlay. Okay. Now, we're going to do router EIGRP10. That's going to be our autonomous system number. So let's go ahead and advertise what networks. We're on the hub, right? So we want to advertise the 192.168.10 network, which is going to be that LAN, that local area network there. Oh, wildcard mask of that. Now on the hub 2, this is going to be our GRE network space. So our GRE tunnel is going to have the interface tunnel IP address of a 172.16.10.1 is going to be our hub, and then the spoke is going to be 172.16.10.2, and then so on and so forth. Spoke 2 is going to have 10.3. Okay, so we're going to advertise 16.10.0. Okay, so that takes care of the router EIGRP. We'll go to our spoke 1. We'll do the same thing. Oh, router EIGRP10. We'll do network. Here we're going to advertise our LAN as well, 20.0. And we're also going to do our 172.16.10.0, which is our GRE. That takes care of that. We'll go to spoke 2, do the same thing. Router EIGRP10 network 192.168. This is going to be a 30 LAN, and then also network 192.16.10.0. Okay, so that takes care of the EIGRP overlay, right? But as you see here, we don't see anything, no adjacencies, nothing, right? We're advertising, but we don't see any EIGRP routes. We only have RIP, and why am I not seeing these, right? Okay, that's because we haven't done the tunnel configuration yet. So we'll get to that. We haven't fully completed task 2 for the overlay, so let's go ahead and get started. We're going to start doing phase 2. So we'll do interface tunnel 0. Okay, on the hub. IP address is going to be 172.16.10.1. Okay. Put an IP address. Tunnel needs a tunnel source. I'm going to use Ethernet 00, which is this guy right here. You can use the IP address of the physical IP address. It's really up to you, preference-wise. Now, for the hub, you have to put, for a regular GRE point-to-point, you would do a tunnel destination. But for the hub, you're going to do tunnel mode GRE multi-point. Now, the tunnel is going to be coming up. There you see. Now, I'm going to go ahead and do the tunnel configuration for the hub, then we'll go over to the spokes. So for the hub, we're going to do tunnel key 123. That's just for the tunnel. IPMTU 1400. IP TCP adjust maximum segment size of 1316. Some of these I'm just going straight ahead without an explanation, just to really explain the DMVPN parts and NHRP. Okay, so we got the tunnel key. Now we're gonna do the NHRP. So next hop resolution protocol is the protocol that's used to connect the whole DMVPN architecture. Sorry. So if we do a quick question mark of IP NHRP, you see there's multiple things to do here on the hub. And really what we're worried about right now for phase 2, since we're on the hub, we're going to put NHRP authentication. We're going to do just Cisco 123 for the password. IP NHRP, we're going to do map multicast dynamic. Okay, now what that says is dynamically learn destinations from client registrations on the hub. So this is the command that we want on our hub. And we're going to do the network ID, which is the NBMA network identifier. This is locally significant. I'm going to use 1, and then I'll use something different on the spokes just to show that as well. And really, that's all you need right now for the NHRP to work. There are other commands that I will put in, but I just want to do this first. That way I can show you. So that takes care of the NHRP configuration on the hub. Now we'll go to spoke 1. Okay, we're going to configure the interface tunnel 0. IP address is going to be 172.16.10.2. No shut. Tunnel source is going to be, you can do, I'll just do it just to be sure that it can be done. 2020.1. Now, if we were doing phase 1, I would be doing tunnel destination. But we're doing phase 2, tunnel mode, GRE, multi-point. Tunnel should be coming up. There we go. Now we're going to do some of the same things. Tunnel key 123, IPMTU 1400, IP TCP adjust maximum to 1360. So that's the tunnel. Now we're going to do IP and HRP configuration. Authentication was Cisco 123. This has to match. Network ID. We'll do network ID of 2, so that way it won't match, because that way I can show that it is locally significant. IP and HRP. Network ID is done. Authentication. Now, there's 2 ways to map the server, right? It's called a next hop server right here. This is the hub. Okay, the next hop server is going to be 172.16.10.1, that tunnel interface. Now, the NBMA, which is the network non-broadcast multiple access IP address, is going to be 10.10.10.1. Okay, so we're going to do, I'll show you right now the one command to map and specify the next hop server. So we want to do IP and HRP next hop server. Now this shows right now, this what helps me remember is protocol IP of the next hop server. So if it says protocol, I'm going to kind of assign that to the tunnel interface. So 172.16.10.1. And if you hit a question mark, again, it shows you NBMA. So I type in NBMA, IP address of that physical interface, and then at the end of it, you hit multicast, which is going to allow you to map that IP address. This is basically what we're saying with this command. Hey, the next hop server is 172.16.10.1. The NBMA IP address is going to be 10.10.1. And then I want you to map it via multicast. So we're going to pair 172.16.10.1 is going to equal to 10.10.10.1. We hit that up. Okay. Now, immediately after I hit that, we have a neighborship formed in EIGRP. Our neighbor is 172.16.10.1. So the tunnel is up. To show IP EIGRP neighbors. You can see our neighbor is here. Our neighbor is 172.10.1. That's good. Okay. So we'll do show IP route. So I did show IP route. I see EIGRP. We see the address of 192.168.10.0. That's good. Now, I'm not done yet. I'm going to do spoke 2. Now, this configuration is not complete yet. I do want to reiterate that. I'm going to do spoke 2 right now, and I'll come back and show you what the missing configuration is, because it's very important, and I want to show you when I have the 2 spokes up how it looks without this configuration. So we'll go to spoke 2, and we'll kind of run through this pretty fast here. 10.3, no shut, tunnel source, 30.30.30.1, tunnel mode GRE multipoint, IP tunnel key 123, IPMTU 1400, IP TCP adjust 1360, IP and enterprise network ID. We'll just put a 3. Authentication Cisco 123, IP map. So this is the 3 command mapping. So IP and HRP next hop server of 172.16.10.1. So if I hit enter there, okay, I'm doing the next hop server. Now we'll do the map command, which is going to be IP address of destination. So this is going to be the protocol IP, so the tunnel, and then we're going to put IP of the NBMA address. Now here you see it says it doesn't let you do multicast, right? So now you're mapping, you're physically telling it, hey, this is, packets for 10.10.10.1. It's going to go for 172.16.10.1. You're kind of pairing them together, right? Now that's the second command. The third command is map. You're going to see multicast. I'm sorry, 172.16.10.1. Oh, nope. So we map multicast to the 10.10.10.1, right? So IP of NBMA. So that's what's gonna map those together. Now, if we do a quick show run interface tunnel 0, also you see the neighborship came up. That's just what it looks like. Next hop server, and these two commands, right? Whereas personally, I like the other one. You can do one command and gets it done, right? So here, if we do a show IP route, we have one known EIGRP route. It's very interesting, isn't it? So we have 192.168.10.0, okay, and I have left out configurations on the hub currently, okay. So I wanted to show you. Let's look at here. I'm at spoke 2. This is our topology. I'm at spoke 2. Okay. The goal is to have the traffic go from spoke 2 directly to spoke 1 and then to PC10. Okay, so I'm going to do a trace route from spoke 2 to PC1. Okay, to have spoke to spoke communication. Now let's see what happens when I do that. So we'll do the spoke 2. We're going to do a trace route to 192.168.20.10, which is this PC here. Okay, nothing, right? And that's because, one, I don't actually see the 20 network, okay? So the missing configuration is on the hub. Now this is very important. We're going to go to interface tunnel 0, and we'll do a no IP EIGRP, no IP split horizon EIGRP 10. Now split horizon is enabled by default, right? That stops, this network is being advertised to the hub through the tunnel interface, but by default, it's learned from the tunnel interface, but it does not allow it to go back out, and the hub doesn't allow it to go back out that interface and get advertised, passed along to the spoke 2 by default. So I disabled no IP split horizon, EIGRP 10. So now let's go back to spoke 2. One, let's see if it's in our routing table now. And there you go. You see the 20 dot network in the routing table. We'll do a trace route. And right now you see the first trace route goes to 172.16.10.1, which is the hub, and then 10.2, which is spoke 1, and finally to its destination. Still, this solves one problem, but it doesn't fully do what phase 2 is supposed to do. We're supposed to directly go from, the first packets should be going through the hub, that's correct. But then you should be going straight to 10.2 and then 20.10. Now, why is that? That is because we have not done the configuration, something else called no IP next hop self EIGRP 10. You see the neighborships forming there. Let's go back to spoke 2. IP route is going to be the same. Now, by default, the next hop self is this hub. We just took that out. It's basically telling itself that, hey, come to me for any kind of traffic to the 20 network. We took that off, and now you can see that our traffic is going from spoke 2, 172, spoke 1, and then here. So now our traffic is going from spoke 1, spoke 2 to spoke 1, and to PC10. And this is what we want, okay? This is phase 2 right now. Now, right now, there are a couple limitations on phase 2, from my understanding. You cannot perform summarization on the hub router. Well, you can, but you will not be able to use spoke-to-spoke communication if you're trying to communicate with that summarized network. And I'll show you that as well. So as you just verify again, spoke to, right? We're trying to access the 172 or 192.168.20 network, right? It works perfectly. Trace route again, it's still doing it. Perfect, right? And then we'll do our show routing, show IP route. How do we know this, right? EIGRP, it's a /24, perfect, not summarized, okay? So just to show that, the transition to phase 3 and why this is important. So here on my hub, I've just created a loopback 4, loopback 10, 192.168.50.1, and a 40.1. Okay, so I'm just going to summarize these and interface tunnel 0. Now, how do we summarize? We go to the interface and EIGRP, IP, summary address, EIGRP, autonomous system 10. I'll go ahead and just do a dirty one, 192.168.0.0/16. Okay, so now I'm summarizing these networks on the hub. Now you see the neighborship, resyncing. We'll go back to spoke to. You can see right now our 10.network and 20.network, they're known with a /24 via 172.16.10.1 and 2. Okay. We'll do a show IP route. Now we only have one EIGRP route in our routing table. Okay. Very important. Whereas we had 2 that were more specific routes. Now there's only 1. Now, how does that affect our trace route? Wow. Okay, so now it's changed. Now we're going back to the hub of 10.1 and then the spoke 1, 10.2, and then to our destination. So that's one of the limitations that phase 2 has. Okay, now how do we overcome this? Let's say if, that can be a big problem if you have a lot of summarizing networks and DMVPN architectures. That's huge, right? That defeats the whole purpose. So now what was created was DMVPN phase 3. In order to solve this, very simple, we're going to leave those summarized networks there just to show that trace route's still there. We're going to go to the hub router. Now this is the configuration that allows you to go to phase 3 of DMVPN, interface tunnel 0. On the hub, we're going to do IP NHRP redirect. Okay. Now on the spoke, on both the spokes, we do config T, interface tunnel 0, IP NHRP shortcut. We'll do that on spoke 1 as well. We do shortcuts on the spokes and redirect on the hub. Okay. So now we'll do a trace route to 192.168.20.10 again. Okay. First traffic. Oh, there we go. First traffic goes to the hub again. Perfect. Let's see what happens when we do the second one. There we go. Goes straight to spoke 10.2, and then to the destination. Now, how does that work? Okay. If you do a quick show IP route, where we have the summarized route here, which is totally fine. Now we have a H, 2 H's here, in our routing table. What is this? This is, fairly new for some people that, don't do phase 3. If we scroll up, what does H mean in our routing table? H is NHRP, Next Hop Resolution Protocol. So, those commands actually allowed us to put the spoke, our peer spokes, into the routing table, which makes it directly connected via the tunnel. Okay, so now it's a better match. It's directly connected. It's better than that summarized route. And we're going to go ahead and use, if we need to get to the 192.168.20.10 network, we're going to use this spoke. I'm sorry, if we want to go to the 192.168.20 network, it's directly via tunnel 0. So we don't have any shows here via, the tunnel of the spoke. We don't need to go to the hub anymore. So that's great. And some verification commands. We can do show DMVPN. As you see here, it shows your peer NBMA. This is going to be our hub. Physical IP address is going to be our spoke 1 physical IP address. Our peer tunnel IP address, you see here, that's correct, that's correct. And then there's 2 here because we have 2 peer tunnel IPs for DT1. So we have one for 192.168.20 network and then the 20.20.20.1 network. Now these attributes, this is static. This is the first one that we mapped statically to the next hop server, which is the hub. And then DT, where is the T1? Route installed. Okay, so dynamic. So the code is DT1, dynamically learned. So we learned this dynamically from spoke. And then T1, route installed. So there was 2 routes installed from this peer. Okay, now there's another command, show IP NHRP brief. I'm going to expand this a little bit here. Oh, that looks uglier. Now with that brief, we show interface, next hop target, next hop address, and target network. The target network is 192.168.20.network with the next hop address at the very top here. So these are the target networks, and then this is the next hop address. This is the static flag, and this is the dynamic, and a lowercase t is a route. So that's really the big thing in phase 3. That's once you have phase 2 configured, it's fairly easy to get phase 3 running. So yeah, if you have any questions, put some comments down. If I could have done anything better or different, let me know. This is, very good for huge architects. It's scalable, add more spokes. A lot of DMVPN, for example, you can have this hub. You could have a regional hub over here somewhere, and just different branches, and you can have different branches communicating to each other faster. You see a lot of that, for scalability. The original architecture is for DMVPN. That way, you don't know if a branch is going to come up, and you're kind of planning it for expansion. And that's, as a good network engineer, you should. You don't want to build an architecture that doesn't have room for expansion. It would not be fun. But yeah, let me know how you like the video, and I'll be posting something else soon. Thank you.